Saxon Algebra 1/2 lesson 52. Congratulations, you made it to the last lesson of the first week back from Christmas break / into 2021. I hope that your brain feels good. We are going to talk about order of operations, and we're going to talk about using fractions with symbols of inclusions. And I didn't want to write out that big long thing. I'd rather just have you write that and go, oh yeah, those are symbols of inclusions. Order of operations. Let's see. The first thing we always do is those. Then, if we have any roots or exponents, we deal with those. Then we multiply or divide. Then we add or subtract. Again, you guys, on a test, I want to see this chart. I don't think I took off for this, but I took off for not writing other formulas. And in the future, I will take off for this too. I was nice the first time. But now I'm done being nice, you guys. So what we're going to do is we're going to have symbols of inclusions with fractions, and that's just going to make it a little crazy. So let's try one. I'll squeeze it in here. Writing these is sometimes the hardest part. Okay, now, when we're doing these, we can see that sometimes, if we're adding or subtracting, we have to make our denominators match because we have fractions, right? And sometimes students say, okay, let's just fix them all at the beginning. I do not recommend that because they don't all need necessarily to be fixed, because when we multiply, we don't need to change them. So, and you never know how things are going to reduce within the problem. So my advice is don't worry about fixing all of them. Just fix denominators when you need to. All right, so that's our keep it simple mantra, hard at work here. So the first thing we're going to do is symbols of inclusion. So we look for them. Oh, here they are. So we need to do the work inside first. Okay, now I see I have to add these, and we do have a denominator issue. So I'm going to see if I can quickly convert this to make it match. And I can see, oh yeah, 4 goes into 16. I'll just multiply this by 4 over 4. And that will give me 4 over 16, right? That I can easily add. Now I'm going to rewrite the whole problem. 3 over 2 times, let's see, that'll be 11 over 16 minus 1 over 8. Okay? Good, I added. Now, I still have parentheses here, but they don't mean symbols of inclusion. They represent multiplication, right? So I don't have any roots or exponents. Now I'm ready to do this multiplication. And I remember that I go straight across the top, straight across the bottom. If I can reduce anything before I multiply, I do that. Oh, shoot, the 2 and the 16, but you can't do bottom to bottom. You can only do top to bottom. So there's nothing to do. So I'm going to say 33 over 32. Oops, I said 32, but I wrote 36, and I'll tell you why. 33 over 32 minus 1 over 8, right? So now we're ready to do the last bit, which is this subtraction. We need to change this 8 to match to 32. We can do that by multiplying. This time I have room, so I'll show it. By 4 over 4, so I'm going to get 4 over 32. So I'm subtracting 33 over 32 minus 4 over 32. I'll write the answer over here. That is 29 over 32. 29 is prime, so I know I can't reduce. That's my final answer. Okay, these aren't really harder. They're a little messier. You just have that dumb denominator issue that you always have to wrestle with. Not dumb. Did I just insult fractions? I think I did. Oops. Let's do another one. Now this one, I'm copying happily away, and I get to a mixed number. It says to write 3 1/4 right here. I don't want to write a mixed number here, so I'm going to immediately convert it. 13 over 4, right? So that's what the book says, but I'm not going to write that because I'm against mixed numbers. Minus 1 over 8. My husband's watching football and complaining, so you're going to have to edit that out if you hear it. Okay, so this is exactly what's written in the book, except this fraction was written as 3 1/4. I converted it immediately. Yay. Okay, now I'm ready to look at my order of operations. First thing I do is work within the symbols of inclusion. So I'm going to do this step. Denominators have to match. This I can multiply by 2 so that I'll get 8 on the bottom. So this will become 26/8. Okay, recopy. 1/3 times 26/8 minus 1/8 is 25/8 plus 1/48, right? That I just copied. Stays, these parts just copied. All right, now none of this. So now I'm ready to multiply or divide. Here's a multiplication, right? It looked like, see, first we did this. So let me draw that line. This still has parentheses, but now they mean multiplication. So I'm down here, and I can't cancel anything before I multiply. So I'm going to get 25/24. Remember, we just multiply straight across. Plus 1/48. Okay, now notice John is being quite kind to us with these denominators. This is not hard to fix either, is it? 24 into 48, we'll just multiply it by 2/2, and we'll get 50/48. And when we add it together, we will get, I'm going to go this way, so I have a little more room, 51, right? Here it is, over 48. And the interesting news is that 3 goes into both of these. Let's check. 5 plus 1 is 6. 3 goes into 6, so that works. 4 plus 8 is 12. So 3 goes into 12, so that tells me 3 must go into this too. And I could do the divisions on both of those, but I'm just going to gift you with the answer. It's 17/16. Okay? If you divide both of these by 3, I'm running out of room. That's the only reason I'm not showing you. 51 divided by 3 is 17. 48 divided by 3 is 16. I knew these were both divisible by 3 because I added the digits as if they were individual numbers, and the sum was divisible by 3, right? 5 plus 1 is 6. 4 plus 8 is 12. Okay, so that's the correct answer. Yay! All right, we have one more. And guess what? It's going to get messier. 52.3. Ready? You know you're in trouble when you get this, when you get symbol inside symbol. Okay. I'm trying to pause to give you time to finish writing. I know it's easy to pause me if you're just sitting and watching me like on your own tablet or laptop or phone, but if you're in a group setting, then I know it's a mess. Okay, so before we dive into this, let's just look at what's going on. This is multiplied by this whole thing, and inside of it there are 2 clumps. So we're going to fix this, and we're going to fix this, then we'll add them, and then we'll multiply in the end. And I'm going to write my list up here. Notice I changed the order on that. That's okay. We just know that we do them both at the same time. Multiply, divide, add, subtract. I always want to see this list, you guys. Written down on your paper. Do it in your homework. Make it cute. All right. So let's start working on these 2 addition problems. This is addition with a negative number. You can look at it that way. Denominators have to match. 3 goes into 6. I'll just multiply this side by 2, so it will be 4/6. I'll slash it out. I'll copy this. 4/6 minus 1/6 is 3/6, right? 4 minus 1 is 3/6, but I can reduce that to 1/2, right? And I'll just write this here so you can see that's how I got that. 3/6 is 1/2 plus, oh, I reversed the shape of these, right? It should be square on the outside, round on the inside. I just switched it. That was just me being crazy. Okay, same thing here. Denominators have to match. We can easily fix the 3 to make it a 6. We'll multiply by 2, and that will change this into 2/6. Okay, 2/6 plus 5/6 equals 7/6. Okay, and I switched my symbols back. I put rounded and then square, which is how it should be. So this looks crazy, but don't worry. Now I can see that I'm going to have to add these together, and I need the denominators to match. So this really would have been a perfectly useful way to write this answer. The 1/2 doesn't help me. I'd rather have the 6, so I'm just going to cross it out and put that back in, right? So that's why I was happy I wrote that down, and you should always do that. Write down your answer, and then if you want to reduce it, that's fine. But if you realize, oh wait, the reduced form doesn't help me, I actually need it with the 6 on the bottom, there it is right there. Okay, so now we're ready to actually add these two together, right? Oh, this should be squared. Sorry, I'm just going wild with this. 3 plus 7 is 10/6. And this, we could reduce to what? 5/3, right? We could leave it as 10/6, but why not reduce it? I love to reduce whenever I can. So now we need to multiply 5, whoops, I'm just going to write it like this. 2/5 times 5/3. And look, cancel, cancel, final answer. Yay. Remember that if you don't cancel, you'll still get the right answer. Let's just look at it and see. If we would have done 2/5 times 10/6, we would have just gone, oh, 5 and 2, 10 goes to 2 and 1. And then this goes to 1 and 3. And then we would have said, okay, we're left with 2 on the top, 3 on the bottom, right? So we would have gotten the very same answer. This is with reducing, and this is without reducing. And either way will get you the right answer. I just like to reduce whenever possible because that's me, right? I like to keep my numbers small so they stay simple. All right, that is the end of lesson 52. This is getting fancy, you guys. It's getting complicated and crazy. So be proud of yourselves for what you are doing, all right? Kind of complicated. All right, that's the end of lesson 52. That is the complete end of your first week of 2021 math. I hope you enjoyed it as much as I did, and I will see you soon.